Alright guys, today we're going to be talking about section 7.5. This is the last section that we have in Unit 7. So tomorrow, Thursday and Friday this week, we will be reviewing. So on Thursday, there will not be a video, there'll just be a review assignment. I will, probably not have a super official class on Zoom, but if you want to just come in and ask questions about the review or any of the homework, I'll be here during the day to answer any questions you have. So on Thursday and Friday, just plan on checking Canvas and seeing what's there. So on Thursday, there's going to be a review worksheet. On Friday, there's going to be a review activity. So you will be required to do both of those. But as far as class, we won't hold a super official class. I'll still be here, and you can come in and ask questions on either day. Okay? Hopefully that makes sense. The last day of class is Tuesday, so Monday we'll take the test on Unit 7, and Tuesday is a half day, or was going to be a half day for students. It's really just kind of a day to wrap things up, so I won't be holding a class on Zoom that day, but anything that you have to turn in, or any problems or concerns that you have about your grade, you can talk to me on Tuesday about that, okay? So here we go, we're going to do 7.5. So we're going to be using trig functions with Pythagorean theorem together, and we're going to be using complementary angles. So remember, complementary angles are angles that sum to 90 degrees. Our objective for today is we want to use our knowledge of right triangle trig together with the Pythagorean theorem to find trig ratios or find other trig ratios. So you'll see what I mean by that in a moment. Okay. So this asks me to use the given information to 1, sketch a picture, and 2, find the specified trig ratio in fraction form. Okay, so basically all we know right now is that the cosine of x is equal to 2 over 5. So we're going to sketch a picture of this. Maybe, give me a second. Okay, so we're going to go ahead and just draw a right triangle. Right? So here's my right triangle. There's the 90-degree angle. I know that x is one of the angles, and it doesn't really matter which one is x as long as I label it and stick with one. So I'm going to call this angle x. Sounded weird. Anyway, so here's angle x, and I know that cosine of x is equal to the adjacent side over the hypotenuse. So on my diagram, that's what I'm going to put. I'm going to put that the adjacent side is 2 and that the hypotenuse is 5. And then I need to find sine of angle x. Remember that sine is opposite over hypotenuse. So I have the hypotenuse, but I need to find this side over here. So let's call this side side A. So I am going to need to find side A, and I don't know any of the angles, or either of the acute angles here, so I'm not going to be able to use a trig function to do that, but I can use Pythagorean theorem to do that. So I know that a squared plus b squared, and b is going to be 2 here, is equal to the hypotenuse squared, so equals 5 squared. So a squared plus 4 equals 25, if I just square those numbers. To get a squared by itself, I subtract 4 from both sides, so a squared equals 21, and then take the square root of both sides, so a equals the square root of 21. Now I know 21 is not a perfect square. I know it's not going to break down further because it's 7 times 3, and those are both prime numbers with no pairs. So I'm actually just going to leave it in exact form. I'm not going to change it to decimal form here. I'm going to leave it as square root of 21. So now the sine of x is equal to the opposite side, which is the square root of 21, over the hypotenuse, which is 5. So that's what I wanted to find. Okay. So I'm going to use the one that's given to me. I'm going to find that third side, and then I'm going to find the other trig ratio. Okay. So let's try another one. So I want to use the given information again to sketch a graph, or sketch a picture, not a graph. So here's a right triangle. Again, you get to choose which corner is x. So I could say that's x, or that one. Just make sure that you mark it and that your triangle corresponds to wherever you put it. So remember that tangent is the opposite side over the adjacent side. So from x, the opposite side is here, so that would be 20, and the adjacent side is 21, so that would be that side. And it looks like I am looking for the hypotenuse this time, so I'm going to call that c. So I'm going to go ahead and use Pythagorean theorem to find c. So a squared plus b squared would be 21 squared plus 20 squared. Remember, the order doesn't matter here. I could have done it the opposite way. It wouldn't matter as long as c is the one across, and the hypotenuse is c, right? So 21 squared is 441. 20 squared is 400. And that's equal to c squared. So 841 equals c squared. In order to get rid of the square, I'm going to take the square root. So square root of 841 is equal to 29. Perfect square. So c is equal to 29. So now I can find cosine, which is the adjacent side over the hypotenuse. Same angle here, right? So the adjacent side is 21. And the hypotenuse is 29. So the cosine of x would be equal to 21 over 29. Okay, not too bad. So now we're going to talk about complementary angles. So complementary angles add to 90. If I add the two angles together, it will always equal 90 if they're complementary. So we say complementary angles sum to 90 degrees. So what we're going to be doing here is we're going to be looking at these angles. So if this angle here in here is 15 degrees, that means this angle here would be 90 minus 15, right? And that is because this one's 90, and I know that the three angles in a triangle have to add to 180. So because this is 90 of those 180 degrees, I know these two have to make up the other 90. So 90 minus 15 is 75. So I know that this angle would have to be 75 degrees. Okay. So remember, if this is my reference angle, this 15 degree angle is my reference angle, then this side over here is the opposite. And then this side right here would be, well, let's do this because it's talking about sine, right? So the sine would be opposite over hypotenuse. So it would be, let's call it side 1 over side 2. So the sine of 15 degrees, I should have called it A and B. Let's go A and B. So sine of 15 degrees is equal to side A over side B, right? But if I look at the cosine of this other angle, so let's look at the cosine of 75 degrees. That's going to be, this is going to become the adjacent side, right? So if this is now my reference angle, this side's the adjacent side and then over the hypotenuse. So the cosine of 75 degrees is also equal to side A over side B. Okay. So if I use the other angle and switch the sine or cosine, they're going to be the same every time. So because of that, I can take this and I just take and subtract this 15 degrees from 90. Then I know the sine of 15 is going to equal the cosine of 75, or 90 minus 15, right? So find the complement to that angle. So 90 minus 81 is 9 degrees. And then I know that the sine of one of the acute angles is always going to be equal to the cosine of the other. Okay. So if my angle is 90 minus x degrees, right? So 90 minus x degrees. Then when I add that to the other angle, I should get 90, right? So 90 minus x, if that equals 90, that means this angle would just be x degrees, right? So the cosine of x is equal to the sine of 90 minus x. So that's pretty much it for this assignment. The rest of the assignment is review from 7.2 and 7.3. You're going to be finding missing sides and missing angles on the back of the worksheet. And then the very top two questions on the very front are just using Pythagorean theorem to remind you how to use that. So if you have any questions, let me know, and I hope you guys have a great day. And remember, we're going to have review the next 2 days, so there won't be videos with them. They'll just be assignments. And then if you do have questions, just go ahead and hop on to Zoom. Have a great day, guys.